If you think the James Webb Space Telescope has already revealed everything there is to know about the universe, the discoveries you're about to hear may completely change your perspective. Positioned nearly 1 million miles from Earth at the Sun-Earth L2 point, Webb was built to peer farther into space and farther back in time than any telescope before it. Every faint beam of infrared light it captures began its journey billions of years ago, carrying information from an era long before our planet even existed. Scientists expected Webb to uncover breathtaking galaxies and ancient stars. What they didn't expect were observations that seemed to challenge long-standing ideas about how the universe works. Again and again, the telescope has revealed objects that appear too bright, too active, or simply too strange to fit comfortably within existing theories. Some of these discoveries include ancient galaxies shining with unexpected intensity, distant planetary systems that may contain the chemical ingredients for life, white dwarfs surrounded by planets that should not have survived, frozen moons displaying mysterious warmth, and unusual infrared signals that continue to puzzle astronomers. Each observation raises new questions, and together they paint a picture of a universe that is far more dynamic than anyone imagined. For generations, many believed the cosmos was mostly silent and empty. Webb is forcing scientists to reconsider that idea. The farther we look into space, the more we encounter patterns that demand explanation. Most of those patterns are likely natural, but understanding them requires physics that is still being explored. When the telescope began its scientific mission, astronomers knew surprises were inevitable. Webb's enormous mirror and infrared instruments were specifically designed to see through cosmic dust, detect faint ancient light, and observe objects invisible to previous observatories. Yet the greatest surprise wasn't simply sharper images. It was how often those images hinted that our current models may be incomplete. One of the first mysteries appeared surprisingly close to home. Neptune, the icy giant orbiting near the edge of the solar system, had always been viewed as a relatively stable world. But Webb's observations revealed something unexpected. Measurements showed that the planet's upper atmosphere had cooled dramatically over only a few decades. On Earth, a temperature change like this might not seem extraordinary, but for a giant planet so far from the Sun, the finding immediately attracted attention. Researchers searched for simple explanations. Variations in solar activity didn't fully account for the change, and Neptune's own internal heat offered only partial answers. The unexpected cooling suggested that processes inside the planet's atmosphere may be far more complicated than scientists previously believed. Adding to the mystery were subtle variations detected within Neptune's surrounding environment. Some observations hinted at repeating changes that encouraged researchers to investigate whether complex atmospheric or magnetic interactions were occurring. While no evidence suggested anything extraordinary beyond natural physics, the behavior reminded scientists how much remains unknown about the outer planets. Webb then turned its attention towards several of Neptune's and Uranus's smaller moons. For decades, these icy worlds were considered frozen relics, cold bodies that had changed very little over billions of years. But infrared observations revealed surprising thermal signatures on moons such as Hippocamp and Despina. Certain regions appeared warmer than expected, suggesting that hidden geological processes may still be active beneath their frozen surfaces. Even more intriguing, spectroscopic analysis detected complex carbon-bearing molecules on some of these worlds. Such compounds are not evidence of life, but they are important building blocks in planetary chemistry. Their presence raises fascinating questions about how chemistry continues to evolve even in some of the coldest environments of our solar system. These findings remind scientists that worlds once dismissed as inactive may still possess hidden energy and unexpected complexity. If discoveries like these can emerge from planets and moons in our own cosmic neighborhood, what surprises might await among the billions of worlds orbiting distant stars? That question became even more exciting when Webb focused on one of the most famous planetary systems ever discovered, TRAPPIST-1. Located only about 39 light-years away, this remarkable system contains 7 rocky planets circling a small red dwarf star. Several of those planets orbit within the star's habitable zone, where temperatures could potentially allow liquid water under suitable atmospheric conditions. Before Webb, astronomers knew the planets existed, but they knew very little about their atmospheres. Using infrared spectroscopy, the telescope analyzed tiny amounts of starlight passing through the atmospheres of these distant worlds. Every molecule absorbs specific wavelengths of light, allowing scientists to identify certain gases without ever visiting the planets themselves. These observations provided valuable new clues about atmospheric composition and offered researchers their best opportunity yet to investigate whether some of these rocky worlds could support conditions favorable for liquid water.